let's talk about power and energy. Power is a time rate of expending or absorbing energy. The symbol for power is P. Power is a product of the voltage across an element and the current through that element at any instance of time. We know that voltage is equal to the change in energy per unit charge, and we know that current is a change in charge per unit time. And by replacing both voltage and current with their respective formulas, we can cancel out dq, and we can derive the formula for power as dw over dt, the change in energy per unit time, where energy is measured in joules and time is measured in seconds. Power is measured in watts, and the symbol for watts is W. So let's take a simple element, a resistor with a positive and negative terminal, and here the sign of power is determined by the direction of current and the polarity of voltage, and here we introduce the passive sign convention, which follows that if the current enters the positive terminal of an element, then power is a positive value. If current enters the negative terminal of an element, then power at that element is a negative value. If power is a positive value at an element, then that element is absorbing power. If power is a negative value at an element, then that element is supplying or releasing power. The law of conservation of energy states that the sum of power in any given circuit at any instant of time must be zero. Therefore, the amount of power absorbed must be equal to the amount of power supplied at any given time. Going back to the formula for power, we can derive that the formula for energy would be the integral of power between some initial time to some final time. We can also replace power with voltage times current in this same formula. Another formula is that energy equals power multiplied to time. When it comes to paying electric bills, you may be familiar with the term watt hour or kilowatt hour, which is how commercial power is typically measured. Well, through this unit of watt hour, we know that watts are the units used to measure power, and hours are obviously used to measure time. And so we can see that watt hours are just a measurement of energy. If we transform hours to seconds in order to get both of these units into their basic SI unit form, then we can derive that 1 watt hour is equal to 1 watt times 3,600 seconds. And since energy is also measured in joules, then 1 watt hour is equivalent to 3,600 joules. Therefore, 1 watt second is equal to 1 joule. This lecture is included in Unit 1 of our electric circuit analysis series, where we cover basic concepts including charge and current, voltage, and power and energy. The formula sheet for this entire unit is available for purchase at payhip.com/EngineerPeer. Right now, all our formula sheets are on sale for 50% off.